if you take the cross product, which I'm not showing you how to do a cross product, but if you take the cross product of those two vectors, it creates a vector. If you take the length of that vector and divide it by 2, you get the area of that triangle. So you remember that triangle that I talked about that goes from there down to this tip up to there? If I wanted to find the area of that triangle sitting there in three-dimensional space all tilted and crazy in the room, very simple. Take this vector, take that vector, cross them, magnitude of that, divide by 2. I've got the area of that triangle. And that would be an extremely difficult problem to do without vectors. So there is a lot of value to this. Now, the big deal. Here's the big deal. Suppose U and V are non-zero vectors. Okay, so I need to first just make sure you understand that I'm not trying to trick you or anything here. We're starting out with two vectors that actually point in a direction and have some length. Here's what we've got. U dot V equaling 0 if and only if, now I'll explain what that means in a second. I should have put U dot V, not U dot U. I did not mean that. U dot V equals 0 if and only if U and V are perpendicular. This is the beautiful result. Okay, let me explain this little thing right here, if and only if. This really means in math if and only if. Any of you ever seen that before? If and only if? Anyone ever seen that before? Okay, let me explain what it means. Give you a quick little lesson in logic here. If you live in Texas, then you live in the United States of America. Do you agree with that statement? That if you live in Texas, you live in the United States of America. Yes? So one way I could say that is, or the way you could look at this is say, if you're from Texas, then you're US. Does that make sense? If you're living in Texas, then you're US citizen, or not a US citizen. You're living in the United States of America. Yes? Does this statement work the other way around? So if I reverse this, if you're living in the United States, then you are living in Texas. Does not work that way, right? Okay, so this is what we call an implication. If this is true, then this is true. That implication works in this direction only. Yes? Anytime you have an implication that works in both directions, that is a very strong condition. And that's what an if and only if means. An if and only if means that if your dot product is 0, then you must be perpendicular vectors. If you're perpendicular vectors, you must dot product 0. Okay? Very strong. This is very, very strong when you see if and only if. This is a test that we use to check whether or not two vectors are perpendicular or not. Do you all know what perpendicular is, right? 90-degree angle? Now, why does this formula work? Why is that actually true? Well, look at this. It's actually very simple. Isn't that the formula? Yes? The dot product is the length of U, length of V, cosine theta. What if theta is pi over 2? Pi over 2 is 90 degrees, right? What's cosine of pi over 2 is 0, right? So if theta is pi over 2, then basically what we're having here is that u dot v has to be 0. Because it doesn't matter what their lengths are anymore. That's 0, gone. That is a super, super powerful thing. It's a check for perpendicular, I want to say perpendicularity, but that doesn't seem like the right word. There's a more mathematical word that we use for the word perpendicular. Do you know what it is? Have you all ever heard it? Orthogonal. Orthogonal. So we actually call this a check for orthogonality. How do we check whether or not two vectors are orthogonal? So let's take a look. Example. Let's let this vector be u. Let's let this vector a and a plus 5 be equal to v. So I have two vectors there. Find a so that u and v are orthogonal. So I give you a vector. It actually has components. -1, 5. There it is. You could draw it, right? Go and draw the vector. Then I give you some other vector, which is not quite, I haven't given you the exact values of everything, right? And I'm asking you to tell me what the A has to be so that when you draw those two vectors, they are orthogonal to one another. They are perpendicular. So what is the condition that you need to satisfy? You need what to be 0? Their dot product to be 0, right? That's what you need. You just need their dot product to be 0, and they'll be orthogonal. So you want, or you need, in other words, you need that -1, 5 dotted with a plus 5 is 0. That's what you need to happen, don't you? So let's dot these. What's the dot product there? Do your dot product. What do you get? -1 times a. Negative a. Plus 5 times a plus 5, which is 5a plus 25. So I'm just doing just regular multiplication there. Must equal 0. Now you have a linear equation, don't you? There's a little linear equation in A. Solve it for A. What's A? For A plus 25 is 0. So A is -25/4. All right, we still have some more work to do in this section. So you can start trying to do some of the homework for that, but I'll wrap this section up next time, and then we'll move into polar coordinates. You want to get your tests, right? I was thinking about allowing you to do corrections or something.